Yep, so the title of our notes today is Quadratic Functions. Quadratic functions. Quadratic functions. We're going to do two pieces today. We're going to see how when we add parts to our parent function y equals x squared, how it affects the graph. And then we're going to also apply it to story problems when we have a falling object. Okay? When things fall, they follow quadratic functions, right? Because when you throw a baseball, does it go straight forever? No, unless you're in outer space, right? Then you never stop. Who's seen that new movie with Sandra Bullock? Gravity. Have you seen that? I want to go see it. I just hear like amazing reviews.
Mr. Cook said it was awesome.
You're the only person I've ever heard say that it wasn't good. I just heard it's amazing. It's short too. It's only 90 minutes. But I believe when Sandra Bullock like loses control, doesn't she start spinning in space? And she can't stop. Right? Why can't she stop? There's like no gravity, there's no friction to slow her down, and I don't know all the physics terms, but there's nothing to slow her down. So if you start spinning in space, you're just going to keep spinning forever and get really sick. If I was her, I would have thrown up in my astronaut uniform, right, which would be really nasty. Okay? So if you throw a ball, it's going to go forever, but not on Earth. What happens when you throw a ball? It's going to, oh, and did you see everyone's arm movement? What shape did that make? An arc. Aren't quadratics like a curved arc? Yep, so that's what we're going to do some falling objects problems. So our essential question would be, how does the falling object model relate to quadratics? At the end of all of your notes, could someone tell me, that should be a question mark, by the way. Question mark right there. At the end of your notes, could someone tell me what you're supposed to be doing? A summary. Good. The very first sentence of your summary should answer the essential question. We will be turning in our portfolios again the first week of November, which sounds like a really long time away, but it's not. Okay, it's only in a couple weeks. So you need summaries on the end of all of your notes in order to get full credit. So now would be the time to start going back and writing summaries if you haven't been keeping up on that. Yes? I will in a minute. Okay. The first example we're going to do is see how we're going to graph two graphs on the same coordinate plane and see how they're related. So how are the graphs related? We have y equals x squared and y equals x squared minus 3. Okay, I'll come get those folders now. And while I'm grabbing the folders, what I would like you to do is make your xy table and fill it in for the x squared. Okay, fill it in for the x squared. Remember, we always use -3 to +3. Fill in the y's on the x squared. Excuse me. Thank you. Did you guys have a folder? Can you hand me that, please? Thank you. Plug them in. See the equation x squared, all you have to do is take the x and square it. Take the x and square it. Okay, Evelyn? Our first x is -3. What's -3 squared? Yep, positive 9. Okay, going down the row. Alejandra, what's the next y value? Yeah, negative 2 squared is positive 4. Okay, is it Jessica or Vanessa? Jessica. Okay, Mora, right? Yes, okay. It's got the last name. Negative 1 squared. 1. Okay, Alyssa, what's 0 squared? Ah, Susanna? 1. Carlos? 4. And Valeria? 9. Good. Okay. Now, we're going to go through and fill in a chart, XY table again. We use the same X values, negative 3 to positive 3. Okay, now we've already done the squared, guys. All you have to do is subtract 3, right? X squared minus 3. You've already done the square. Now subtract 3 and fill it in. And I'm going to pass out rulers and some crayons. Now the rules with the rulers are, don't hit anyone, don't slap them on your desk, don't spin them on your pencils or pens. Basically, the only thing they should be used for are to measure things and draw straight lines. Are there any questions of what you use rulers for? Because if it's not measuring or drawing a straight line, you're doing it wrong. Okay, fill in the y values for the next equation. Y equals x squared minus 3. We've already squared them, you just have to subtract 3. Okay, thank you. Here's a ruler. We've already squared them. Good. Thanks for subtracting 3. Those look good. No, one was hiding. It was that invisible one. Okay, everyone will also need a baggie of crayons. Lucky for you guys, at the beginning you get the brand new crayons no one's used before. You have a question, Raul? Sorry. Well, it was in the box, so it ended up in the bag. One minus 3. These two are right, but what's 1 minus 3?
Oh, no.
Yeah, you just put 2, but it's negative.
For negative?
Mm-hmm. And then that should be positive 1 and positive 6. Okay, can I have everyone's attention, please? Up here in 5, 4, stop your conversations. 3, 2, 1. Brianna, if we've already squared it, now we just subtract 3. Can you tell me the y values, please, by subtracting 3? 6. 4 minus 3 is? 1 minus 3 is? Negative 2. 0 minus 3? Negative 3. And then? Good. Where it starts repeating, you can see the vertex. Right here is the vertex of this one. Right? Because the y values start repeating. And we have a vertex right here. That's the vertex. Remember, the vertex, if the graph is opening up, is the minimum point. It's also on the axis of symmetry. If the graph is opening down, then it's the maximum point on the axis of symmetry. So now I've given you rulers. We're going to graph this. Okay, make sure your graph isn't itty-bitty. We need the graph to be about 2 inches wide and tall. Before we get too crazy graphing, the x's are what we're used to. There's positives and negatives, but what about the y's? What's the lowest y on this red chart? What's the lowest y value? 0. Take it off your pencils, please. So I'm going to take your rulers away. Hakeem, you too. And what's the largest y? 9. Okay, and here, do we have any negatives? Negative 3 up to 6. So we do need our graph to have just a couple on the negative side and then go all the way up to positive 9. So it doesn't have to be, your x-axis doesn't have to be perfectly in the middle. I'm realizing that my y's have a lot more. It has to go all the way up to positive 9, so it's almost an upside down T. And I put arrows on both ends of all the axes, y and x. And then we're going to evenly space 1, 2, 3 to negative 3, 1, 2, 3 to positive 3. Do your very best to evenly space those. And we're actually only doing one graph. We're going to put both of them on the same graph. Then we need to make sure we go down to negative 3 and up to positive 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Oops, I actually wanted to go to 10, but that's okay. 6, 7, 8, 9, 10. And I like my 5s to be a little longer so I can see them. 1, 2, 3, negative 3. And I do need numbers on both your axes so we know what you're counting by. Because sometimes we don't count by ones. Sometimes it's best to count by a different number, like counting by 6s, counting by 4s. Okay, so you do need to number and label everything on your graphs. Good. And then can you just go through and put numbers on those, please? Thank you. Okay, time to graph. I've given you crayons. Would you pick one of those crayons, please? And we're color coding. Since we're doing two parabolas on the same graph, we're going to color code. So find your equation right here, y equals x squared, and color code it. You can just put a box around it. If it's a light color, I guess you could lightly shade it in. So my red graph is going to be representing y equals x squared. I prefer the points to actually be done in pencil, and then you can use the crayon to graph the parabola. So we're going to graph negative 3, 9. Would you go left, negative 3, up to 9. Graph the whole parabola. Negative 2, 4. Negative 1, 1. 0, 0. And then you can use symmetry from then on. Oops. Okay, make the points nice and large so that when we put the parabola through it, that we can still see where the points were. Then you can use your crayon so that they're color-coded, and make sure at the very bottom it's curved because it's a U, right? It's not a V. A V is something else. And at the top, put arrows. At the top of your parabola, put arrows because it does go up, up, up forever. Good. Okay, now take your second color, and once again we're going to color code. So like if I want mine in blue, I come over here to my equation and I make sure I color code that the one in blue is this one. Y equals x squared minus 3. And then graph it. Okay, can you graph the next one, please? Where is negative 3, 6? So start at the origin. Right there. Negative 3 means we go left, negative 3. So this one is your left and right movement. This one's your up and down movement. Okay, then you go up to 6. Okay, put a point. Good. Now start at the origin again. Origin's where they cross. Go to negative 2. Good. And then go up 1. Okay, put a point. Okay, does that make sense? Keep going. Stop, please. Mine's blue, yours is probably a different color. I go left negative 3, up 6, left negative 2, up 1. For negative 1, negative 2, that means you go left negative 1, down negative 2, right? And then 0, negative 3, 1, negative 2, 2, 1, 3, 6. I want you to turn to your neighbor and, well, first I want you to hypothesize. Make a prediction. Look, these equations are almost the same. The only difference is my blue one had a minus 3. So how are the graphs related? I want you to, in your head first, make a prediction that when we minus 3 from x squared, hypothesize what just happened. Okay, be specific too. Then I want you to turn to your neighbor and tell them what you think just happened when we put a minus 3. Turn to the neighbor right next to you and tell them when we minus 3, what just happened to our second graph. Turn to your neighbor and be specific. Uh-oh, I'm missing a remote. There it is. Oops, what's wrong? Don't restart the program. Exit. Oh, great. Okay, if you want to volunteer your neighbor's hypothesis, please raise your hand. Okay, who are you volunteering? Okay, Brayden, what's your hypothesis? Okay, wait, sorry. People aren't listening. You ready? Brayden's going to tell us his hypothesis. Oh, why would it go down 3? You don't know? Wasn't there something? What does going down mean mathematically? Subtract 3. Okay, now I'm missing one piece in this. Specifically what? Well, I guess all of them go down 3. Every point goes down 3. But the point where we really focus on is the vertex, right? The vertex moves down 3 and the whole graph moves with it. The graph doesn't change width or anything. We still have the u, and then it moves down 3. The whole u moves down. Okay? So, let's make a prediction. Or hypothesize what, this is called a vertical shift. Vertical shift will happen. I'm going to give you a few equations, and without graphing, we can predict what will happen from the parent function. Can you put that down, please? Down, flat, on your desk. You're not using it right now. Example 2. If I give you this equation, Valeria, would you close that door, please? I don't know what they're laughing at, but they're sure disrupting us. Thank you, Valeria. Y equals x squared minus 5. Please turn to your neighbor after you write that down and tell them what you predict will happen to the graph. Okay, Raul, I didn't see you talk to anyone. Gustavo, did you talk to someone? All right, who wants to volunteer their neighbor? Hakeem, who are you volunteering? Okay, Sean. Everyone focus this way, please. I know, I'll tell you about the sodas in a minute. I'm waiting, please. Sean, what do you predict will happen to this?
I predict that the vertex will go down 5 and the whole graph down with it.
Yeah, so let's call the vertical shift down 5. Because of the minus 5, that's going to be a vertical shift down, ooh, that's a big arrow, 5. Didn't mean the arrow to be so large, but down 5. Because of the minus 5. So we don't even have to graph it to know what's going to happen. Vertical shift down 5. Okay, I want you to write the next one down. Y equals x squared plus 4. Okay, and then turn to your neighbor and predict what will happen. Okay, come back to me please in 3, 2, facing forward, 1. Lorena, what do you think is going to happen? Vertical shift, up 4. Good. Vertical shift, up 4. Okay, vertical shift up 4. After we finish the notes, remind me to talk about the pops. That's after the notes. We have one more example, which will be our following objects model. So remember, at the beginning of class, we talked about following object. We talked about throwing a baseball and the shape it takes. So example 3, a following object model. Following object model. I'm going to bring up a problem. You're going to copy down the problem, and then we're going to work it out. What's in your lap, Tristan? Okay, unfortunately the program I had closed, so let's hope it's still in my copy and paste feature. And I will just paste it. Nope, that's not it. Okay, so yeah, if you run out of room, go ahead and go to the back. Here it is, but I need to make it larger because the zoom feature doesn't work. Okay, whoops, too much. For example 3, please write down the following problem. That's about as large as I can get it. Let's see if that made it larger without it coming off the screen. I will read it to you. Ooh, barely fits. Okay, example 3, write this down. I will read it to you, especially those in the back. An acorn drops from a tree branch 20 feet above the ground. An acorn drops from a tree branch 20 feet above the ground. The function h equals negative 16t squared plus 20. The function h equals negative 16t squared plus 20. Are you writing this down?
I thought we just had to write down the equation.
Nope, the whole problem. If you don't have room, flip it to the back. So we need room underneath it to solve. That function gives the height h of the acorn in feet. And after t seconds, again from the beginning, an acorn drops from a tree branch 20 feet above the ground. The function h equals negative 16t squared plus 20 gives the height h of an acorn in feet after t seconds. We have two questions. What is the graph of this quadratic function? What is the graph of this quadratic function? And at about what time does the acorn hit the ground? Question mark. And about what time does the acorn hit the ground? So, whenever we have story problems, lots of the time it's very helpful to draw a picture so you can see what's happening. So if we were to draw this, what would we draw? A tree, right? You even have crayons, you can color it in. So we need a tree. Thank you. I know, it's lovely. What else do we have with this tree? An acorn and a branch. Okay. A branch is sticking out. And what happens to this acorn? It falls. And we talked about it. It doesn't go straight down, does it? There's a little bit of an arc to it. Okay, so the acorn falls to the ground. And at the ground, I'm going to draw my acorn. The ground represents your x-axis. Because if we're on the ground, what's our height? 0. If we're on the ground, we're at height of 0. Where did this acorn start? 20 feet high, right? So where this branch is, that is our y-axis. Where this branch, this is our y-axis. And the branch is 20, what's the unit? Feet. If the y-axis is feet, what's the x-axis measuring? Ah, very good. Seconds. T in seconds. Good job. The other class didn't get that. Great job. T in seconds. So we've answered the first one, was the graph of this function. We've drawn it. Now we have to answer the second part. At what time does the acorn hit the ground? Okay, so we have this function, h equals -16 t squared plus 20. And we've already noticed if after the x squared, or in this case t squared, there's a plus 20, what type of a shift is that? Vertical shift? Up. But is our t squared positive or negative? Negative, so it flips the graph down, which is why the acorn's falling down. So our vertex is not at 0, 0 anymore, it's at 0, 20. Or 20, 0, excuse me. 0, 20, sorry. Got a little brain fart for a second. 0, 20. Okay, so it's shifted up. Okay, we can figure out how much time it takes for it to land when the height is 0. Because which one of these two variables represents height? H. And what is H going to be when it's on the ground? 0. So H equals 0. And then all that's left is t, time. And now we can solve for time. Just like when we solved our ACT review question at the beginning of class, we do the same thing here. We use inverse operations to solve. And you get t all by itself. So solve it for time. Solve for t. We did a problem at the beginning of class today where we solved for the variable. It's the same thing here. Solve for t. Solve it. Don't just stare at me. Solve for t, please. Anything that's next to t needs to be moved over to the left-hand side. It would help if you just wrote it on paper. Use inverse operations. Here's a hint. Generally, when you're solving, you want to make sure you undo addition and subtraction first, then multiplication and division second. Solve for t. Okay, that's a lovely tree. Now can you solve for t? Come on, girls, solve for t. Is there any addition or subtraction in this equation, guys? Yeah, so what's the inverse of adding 20? Minus 20. That's what you're supposed to do first. Subtract 20 on both sides. This isn't something new. We've been doing this since 7th grade. Okay. Now you have to move the negative 16 with inverse operations. The first two questions in your homework are following object problems like this. Okay, so you're going to have to do these on your homework. That's a lovely tree, Carlos. Okay, how do we get rid of the negative 16? What does this say? Negative 16 plus t squared?
No.
Does it say negative 16 minus t squared?
No.
Does it say negative 16 times t squared? Yes! Gerardo, what's the inverse of timesing?
No. Adding?
No, the inverse of timesing, or the inverse of multiplication.
Little x. I don't know.
Is it add, subtract, or divide?
Oh, divide.
Divide. So now we have to divide both sides by negative 16. Negative 16 divided by itself is 1. It cancels to 1. Okay, what is a negative divided by a negative? Positive, so we don't have to worry about signs. Okay, I can do this without a calculator, right? What divides into 20 and 16? 4. 20 divided by 4 is 5. And 16 divided by 4 is 4. 5/4 is the same as 1.25. That equals t squared, which is great, but we want to know what t is. Raise your hand, don't shout it out. Raise your hand if you know the inverse operation of squaring. What's the inverse operation for squaring? Thanks for raising hands. Inverse operation of squaring. Because the inverse of adding is subtraction. The inverse of multiplying is division. The inverse of squaring is... kind of.
Square root.
Square root. Is that what you're going for? Okay, square root. So we're going to square root both sides. So square root of t. Now, guys, if you take the square root of 4, there's actually two answers. Plus and minus 2, right? Square root gives you a positive answer and a negative answer. But does it make sense in this problem to have negative time?
No.
No, because I don't have a time machine. Pretty sure the squirrel who threw the acorn out of the tree doesn't have a time machine either, right? No time machines. So we only look at the positive. So those who have calculators, do it please for us. We need the square root of 1.25. Square root of 1.25. Thanks for plugging it in. Square root of 1.25. And this is a story problem. So with our answer, we should always put a unit. It's not feet, actually. T. Seconds. Okay, 1.25. Someone I don't hear from very often. Who has it? Alejandra? Square root of 1.25. It's a decimal. Perla? And then after the 11 is in an 8. So we'd say 1.12. 1.12 seconds. 1.12 seconds. So the first two problems on your homework are following object problems like this. So you need to draw it like we've done, solve it, and remember you need a unit on story problems, always. You have to explain what your answer means. Now today I'm going to give you graph paper. I do not want you to do your homework in the book because at the end there's just not enough room. Okay, so I'm going to give everyone graph paper and that will help with the graphing anyway. While I'm getting some more graph paper and passing it out, please pass in the rulers and the I didn't pass erasers out to everyone, did I? Okay. And then I will write down what the assignment is.
But I can make this in your green basket.
You know what? I bet you probably can too. This is the graph paper that you will do your homework on. Yeah. You only had 8 problems all week. 4 problems last night and 4 problems the night before. I think having Homework this time. I was trying to grab it. You could nicely hand that to me. I think having homework over the weekend isn't going to kill you. This is called school. It's called homework for a reason because you do it at home. Please collect those. Okay, have a seat. We're going to start. Hey, no. Your seat's over here. Okay, our assignment, which on this graph paper, since you're all doing it on the graph paper, you need to, in the top right corner, put your name. Please leave, you're not, I don't even know who that is, but there. Okay. At the top right corner, you should put your first and last name, and your class period and the date. 4B, today is October 11th. Also, since it's on a separate piece of paper, we need to write down the assignment on your graph paper. The assignment is page 712, 9 through 16, 28 through 35. Okay, we are working through the end of class on this. If you don't take me seriously, I can give you 3 more problems like last class got. Okay? So I hope you'll take me seriously that we're actually working. It's not party for the rest of class. We're going to be working. It is in your book, so you will have to use your workbook, but we're doing our work on the graph paper. The back side of the graph paper is blank. So only if you need to graph it, do it on the graph paper. If it's not a graphing problem, do it on the blank side. So get your books open, please, to 712. And let's start. Number 7, or page 712, number 9. There are a total of 5 problems that you actually, I believe, will be graphing. Yep, just 5. So, if it's not a graphing problem, do it on the blank side. Otherwise, Tristan, can you have a seat, please? Like your seat's this direction. Pretty sure if you read the rules of class, please raise your hand for permission to get up. Yeah.
Do we need to write the whole story on there?
No. No, just write number 9. Okay, this is a graphing one. If you read it in advance, it's a graphing one, so you should be on the graphing paper side. Tristan, can you flip your paper over? Because we're going to need the graph area. Raul? Yes, thank you for asking. Okay, what we should do, though, when we read the problem, is at least write down the important information. So who has a loud, booming voice who can read number 9 for us? Okay, Jared. And we're going to write down as he reads.
A person walking across a bridge accidentally drops an orange into the river below from a height of 40 feet. The function h equals -16t squared plus 40 is the orange's approximate height h above the water. After 2 seconds. Graph the function and how many seconds for the orange to the water.
Okay, many seconds to the water. So I just wrote down the important pieces, right? The orange falls from a bridge, okay, from a height of 40 feet, which is why it says plus 40, right? Because it's a vertical shift up. When we're falling, we're going down. That's why the equation is negative, and the graph has been flipped. It's a parabola facing down. So let's graph this by showing, what picture should we draw? A bridge. It's not a tree this time. It's a bridge. So you can draw your bridge however you want. Maybe, I don't know. Okay, here's my bridge. Yay, okay, bridge. Why isn't it graphing? Bridge. Yay, okay. Awful bridge. There's my bridge. Okay? And from the bridge falls an orange. But remember, when things fall, they kind of fall at a parabola. And the bridge here is 40 feet high. Yes? Oh, and I forgot the E on orange. By 9. We're up here. Raul, up here? Oh, orange, sorry. I forgot the E. Okay, the orange falls down and hits the water. The water is representing which axis? Good job. So let's label that. The x-axis. The bridge, the height of the bridge is the which axis? Y. And I've already labeled its unit. The y-axis is representing what unit?
Height.
Height in feet. Versus the waves, the x-axis will be representing what unit? Time. Are we in minutes or hours or seconds? Okay, so you're done with half the problem. You should have graphed that, and you have graph paper, so it should be looking nice and neat. And now you have to find how many seconds will it take for the graph to hit for the orange to hit the water. If we're hitting the water, what's its height on the water? 0. Okay, so just like we did last time, the height is 0, and the unknown value is the time. So you just solve it, just like we did on the last problem. Solve it for time. Make sure when you write your answer, you say T equals, and what's the unit that goes with it? Seconds. Seconds. Story problems have to have a unit.